This video goes over the elimination notes. So we look at the X column and we look at the Y column, and we're looking for ones that have the same number. Y's have 1 for both. So for sure we're going to be eliminating Y. The question is, how do we get there? If we add or subtract, how do we get 0? So notice this one has a plus and a minus. That means if we add, we get 0. So we're going to add to eliminate Y because the signs are different. Number 2, the 7x column have the same number, so for sure we're going to eliminate x. And notice that this one is plus and this one is plus. That means we'll have to subtract to get rid of it. We can't just add and have it cancel out. Number 3, the y column have the same number, so for sure we're going to eliminate y. Notice one's a plus, one's a minus, so we can go ahead and add these to eliminate. Number 4, the x column has the same number, so we're going to be eliminating x. Notice this is a minus, this is a plus, so if we add straight down, they go away. Number 5, the x column has the same number, so for sure we're eliminating x. Notice one is a plus, one is a minus. That means if you add, they go away. Now we have to actually finish the problem. So the first thing we're looking for is I see an 8 and I see a negative 8. That's good. You have to see the same number, same letter, and a plus and a minus. When all those things are true, we can add straight down all 3 columns. So we do 10 minus plus a negative 8x, and that's 2x. The y's just go away. You could write 0y if you wanted to. And this gives me 2. I divide by 2 on both sides, and I get x is equal to 1. Halfway to my answer, let's drag over one of these equations, like let's say this one, and let's plug in 1 where there used to be an x. So this tells me that 10 plus 8y is equal to 42, and we're back to two-step equations. We subtract 10 from both sides to get 8y is equal to 32. We divide by 8 on both sides to get y is equal to 4. I have both of my coordinates. This is the complete answer. Number 7, I see that my y column already has the same numbers. Is one a plus and one a minus? No. So what I'm going to do is I'm going to take this top equation, I'm going to multiply the entire thing by a negative 1. If I rewrite that, I have negative x plus 10y is equal to negative 18. And now I'm going to cross out that equation because I rewrote it slightly different. At this point, I can add the columns straight down, negative 7x. The y's cancel out, one is plus, one is minus. And if I add 32 plus a negative 18, I get 14. I divide both sides by negative 7, I get x is equal to negative 2. Let's plug that into one of my original equations. Negative 6 times negative 2, I'm plugging in for x, minus 10y is equal to 32. This is 12 minus 10y is equal to 32. I subtract 12 from both sides. I get negative 10y is equal to 20. I divide by negative 10. I get y is equal to negative 2. Number 8, I'm looking at the x column, and I'm going to multiply the top one by negative 1. That way, after I do so, I have negative 3x. This turns into plus 8y, and this turns into negative 19. I cross it out, and I'm going to add my columns straight down. The x's go away. I have 13y is equal to negative 65. If I divide both sides by 13, I get y is equal to negative 5. So let's go ahead and use one of my original equations, like let's say this one. 3x plus 5 times negative 5 is equal to negative 46. So I took this 5 and I plugged it in right there. This is like saying 3x minus 25 is equal to negative 46. When I add 25 to both sides, this brings me closer to 0. So I'm at negative 21. I divide both sides by 3. I have x is equal to negative 7. Number 9, the y's are the same, but one is plus and the other is plus. So I want to change that. So I'll take a negative on the top one. And now I have 8x minus 9y is equal to positive 21. So let's cancel that out. And then let's go ahead and add all of these straight down. So I have 8 and minus 3, that's 5x. And on the right side, I am at negative 15. If I divide both sides by 5, I get x is equal to negative 3. Let's plug that into one of our original equations. So negative 3 times negative 3 plus 9y is equal to negative 36. That's this equation. and I plugged in this value. 9 plus 9y is equal to negative 36, minus 9 from both sides. 9y is equal to negative 45. Divide by 9, y is equal to negative 5. Number 10, the x's already have 1 and negative 1, so I'm actually good to go. I can just add straight as they are, straight up and down. So I'll do plus, and I'll draw my line right here. The x's go away. I'm at negative 13y is equal to negative 78. If I divide both sides by negative 13, I get that y is equal to 6. Let's plug that back in, and I'll use maybe this one. X minus 6 times 6 is equal to negative 37. X minus 36 is equal to negative 37. Plus 36 to both sides. X is equal to negative 1. With this one, I start to have to deal with least common multiples. So let's think about what's the least common multiple between something like 3 and 5. I was kind of telegraphing the answer there. The answer is 15. Because 3 times 5 and 5 times 3 gives me 15. But what about between 2 and 4? It's not just 8. It's actually 4, because 2 times 2 gives me 4, and 4 times 1 gives me 4. So that value is called the least common multiple, and we use it to help us decide how to set up the problems for elimination. For example here, in my x column, I could double the top one to make them the same. They have a least common multiple of 2. In my y column, I could double the bottom one because they have a least common multiple of 4. So it doesn't really matter which one I choose for this one. I'm just going to pick the y because it already has a plus and a minus. So that seems right. Let's double this. Negative 4x minus 4y is equal to negative 20. And I'm going to cross out the one that I just did, and now I can add these straight down. Negative 5x, the y's go away, is equal to 5. So I divide both sides by a negative 5. X is negative 1. Let's plug that into this top equation over here. Negative 1 plus 4y is equal to 25. 1 plus 4y is equal to 25. Minus 1 minus 1. 4y is equal to 24. Divide by 4, divide by 4, y is equal to 6. For this one, if I look at the least common multiples, it's 6 and 8. I think I would probably take the bottom times a negative 2. What this does for me is my y columns are set up for elimination now. I can add things straight down. If I had chosen a different value, like multiplying the bottom by negative 6, that would have worked too. The negative is just so I have a plus here and a minus here. It really helps because adding is easier than subtracting. Here I have 4x is equal to negative 16. If I divide both sides by 4, I get x is equal to negative 4. Let's plug that back in. 6 times negative 4 plus 8y is equal to negative 8. That's negative 24 plus 8y is equal to negative 8. If I add 24 to both sides, I get 8y is equal to 16. If I divide by 8, I get that y is equal to 2. This one, if I try to do that with 6 and 7, my least common multiple is 42. That's really big. But if I try it here, my least common multiple is 6. And that's a little bit easier to do. I only have to multiply one of them instead of both of them. So that's what I'm going to do here. How do I get from 2 to 6? I multiply by 3. And since I want it to be plus and minus, I'm going to put a minus here. This means I have 18x minus 6y is equal to negative 48. And I can cross out the original one, and now I'm going to add straight down all three columns. 11x, the y's go away, is equal to negative 22. If I divide both sides by 11, I get that x is equal to negative 2. Let's take that and plug it in. So negative 7 times negative 2 plus 6y is equal to 26. That's 14 plus 6y is equal to 26, minus 14 from both sides. 6y is equal to 12. Divide by 6 on both sides, y is equal to 2. If I take this top one times 5, I get negative 15x minus 35y is equal to 25. Then I can cross out my original one, and I'm going to add these straight down. X's go away. I have negative 29y is equal to 58. If I divide by negative 29 on both sides, I get y is equal to negative 2. Let's plug that back in to this second equation here I'll choose. 15x plus 6 times negative 2 is equal to 33. That's 15x minus 12 is equal to 33. I'll add 12 to both sides. 15x is equal to 45. Divide by 15. X is equal to 3. For 15, I'm going to take the bottom one times negative 5. That will give me negative 10 for the x column, which is great because I can eliminate the x's. This gives me positive 50y and negative 50 over here on the right. So I'm going to cross out this one. I'm going to add straight down. My x's go away. I'm at 41y is equal to negative 82, which tells me that y is negative 2. At this point, I'm going to plug back in. Let's do 10x minus 9 times negative 2 is equal to negative 32. Or 10x plus 18 is equal to negative 32. Or 10x is equal to negative 50. Or x is equal to negative 5. These are actually the same. They're just written a little different. So I'll just do this first one. I'm going to rewrite the equation over here. Same thing. And I'm going to multiply this bottom one by 7. And what that does, it gives me negative 21x minus 7y is equal to negative 84. I'm going to cross out this one, and I'm going to add straight up and down. Negative 29x, y's cancel out, is equal to negative 58. So that tells me that x is 2. And if I plug that back in, we'll do negative 8 times 2 plus 7y is equal to 26. Or negative 16 plus 7y is equal to 26. Or 7y is equal to 42. Or y is equal to 6. And the next several are kind of the same, so I'm going to skip ahead to number 21. And now, what happens when we add or subtract some of these? So let's say I added straight down on this one. This gives me 0x, 0y, negative 2. Is it true that 0 is equal to negative 2? That's a false statement. All the letters are gone. It's a false statement. This is no solution. This looks like this on a graph. These are parallel lines that never cross. Next up, let's take this top equation times negative 2. If we rewrite this, we get negative 8x minus 2y and positive 16. Now, if I add these down, on the left, everything goes away. And on the right, I get 6, which is false. This is no solution. These are actually just parallel lines that never cross. That's why it's no solution. But how do I recognize it? The letters go away, and I'm left with a false statement. 0 is not 6. I'm going to skip 23 because it's the same, and let's jump over to number 24. So here, if I take the top one times a negative 5, I get 25x minus 10y is equal to negative 40. I'll cross out that original one there. If I was to use addition straight down, I have negative 2x is equal to 2, or x is equal to negative 1. So already, I know that there's one solution. I could go back and plug in and find out what the other one is, but I have proven that there is one solution. This is like normal, where we have two lines, they cross in exactly one point here. Well, not here for this one, but there's an example. So let's change number 25 a little bit. Let's make this one so that it says on the top negative 10, because I want to give you one of each type, and this one didn't have it randomly. So if I add these straight down, all the letters on the left cancel out. Everything on the right cancels out. This is a true statement. 0 does equal 0, so you'd pick infinitely many solutions. On a graph, this is actually the same line that's sitting on top of itself. So every point is on both lines. How do you recognize it? When the letters go away, you are left with a true statement, like 0 equals 0.